In this lesson we're going to look how the pressure is related to the temperature of a gas when the gas is enclosed in a fixed volume. So for example, let's take this simple experiment here. We've got a nice strong sealed container, and I've got a pressure gauge here to measure the pressure, and we've got a thermometer to measure the temperature. Let's imagine that thermometer is soldered in here. It's a nice good seal here into the container, so no gas can escape from the container. And so the container contains a gas, and this is represented by these particles here, and as we've mentioned before, these particles are moving around constantly at a variety of speeds and directions, completely random motion. They're colliding with the walls of the container, and the pressure is the average effect of the forces produced by those collisions against this wall. Okay, so what we're going to do is we're going to see what happens when we heat up the container, when we increase the temperature. We apply heat, and as a result the kinetic energy of these particles will start to increase. So the average kinetic energy of the particles increases because the temperature is increasing, and therefore the average speed of the particles increases. As a consequence of this, the number of collisions with the wall of the container also increases, and the speed with which the particles collide with the container wall increases. Therefore the forces exerted by these particles in their collisions also increases, and as a result the pressure in the container will increase. So we can say that the pressure inside the container is proportional, that sign means proportional, to the temperature of the gas. There's a small p for pressure is proportional to big T for temperature. Now, one thing we need to point out here, which is very important, is that the temperature in this relationship is not the temperature in degrees Celsius, but it's the temperature in Kelvin. So what this relationship says is that if you double the temperature in Kelvin, then you double the pressure inside the container. Let's put that into context. Supposing that, to start with, before we turn the Bunsen burner on, that the container is at room temperature, that's 20 degrees Celsius, which is equal to 293 Kelvin. Okay, remember that 0 degrees is 273 Kelvin. Now, supposing at the same time the starting pressure in the container is 1 atmosphere, that's roughly speaking 100 kilopascals, then if we double the temperature to 586 degrees Kelvin, then the pressure in the container will increase to 200 kilopascals. That's approximately 2 atmospheres. So this is the relationship between pressure and temperature. We can say that the pressure is proportional, directly proportional to the temperature of the gas. Now if we want to write an equation, let's say get rid of the proportional sign and use the equal sign here, then we need to introduce a constant. So we bring the temperature over to this side and we write pressure divided by the temperature is constant, or in symbol form, the pressure divided by the temperature is constant. Okay, let's just highlight that with the red blocks. This is the important expression that we need to remember, that the pressure divided by the temperature is a constant. And we use this relationship to calculate how the pressure of a gas changes for a given change in temperature in the following lesson.